all chemistry experiments, the first thing is safety. So I'm going to put on my gloves, my glasses, and I'm only going to touch and manipulate the dry ice with tongs. So let's take a look at the dry ice. So notice that the solid form of CO2, or dry ice, is turning directly into the gas CO2 without going through the liquid phase in between. And this is sublimation. The rate of sublimation can be greatly speeded up if hot water is added to it. Notice how much more gas is coming out of the cup now. And now for the actual experiment. Take this container, fill it up with dry ice. Until I get a decent amount in it. Then I'm going to add a little bit of Dawn soap. And the hot water. And watch the bubbles. That is really cool. Because when you pop the bubbles, all the CO2 gas escapes. And this will go on for many minutes. Dry ice is the solid form of CO2, and it forms at negative 109.5 degrees Fahrenheit. If we look at the phase change chart for CO2, notice that at 1 atmosphere of pressure, it exists in only its solid and gas states. If we compare this chart to that of H2O, we notice an immediate difference. That at 1 atmosphere of pressure, H2O exists in its solid, liquid, and gas states. So, CO2 is known as dry ice because in its solid form, when heated up, it goes directly from a solid to a gas without passing through the liquid state, and therefore without leaving a puddle. So basically what happened in this experiment is that when the dry ice was mixed with the hot water, it increased the rate of sublimation. And as the escaping CO2 gas came into contact with the Dawn dish soap, it formed bubbles. They called me mad! Mwahaha! Mwahaha! It's alive! Ah! Spreading. It's everywhere. It's all over the ground. What have I done? What have I done?